Sir.
You're calling me.
Sir.
Vijay. Pintu bomba tentuka menurutku. Kocak.
Assalamualaikum Dr. Saab. खैरियत से? कॉलेज में चले? वैसा कब क्या निकलते आप? 6 5 6 कोई है आपके साथ? हाँ हाँ अच्छा ठीक है ना अच्छा अच्छा कृष्णा सर अच्छा अच्छा मालूम मोटू अच्छा सुनो मैं एक भेजता हूँ कल ही लास्ट डेट है तुम अगर इसमें सूटेबल है तो अप्लाई कर दो ना तो मैं एक भेजता हूँ सेंट्रल गवर्नमेंट के हिसाब से वो अब सूटेबल है तो कर दो कल ही लास्ट डेट है कॉन्ट्रैक्ट बेसिस है लेकिन बहुत अच्छा रहता है अगर इंशाल्लाह उसमें परमानेंट हो गया तो मैं भेज रहा हूँ व्हाट्सएप पे सीधैक बोलते सीधैक जी
Udah, yang kuliah. Tigam. Lu patukan ka?
Good evening, everyone. We would like to welcome Dr. D. Lakshmi, Senior Associate Professor, Department of AI, VIT Bhopal. Dr. D. Lakshmi has been working in the educational sector since 1998. She has published 9 international journal papers, 2 book chapters, and presented papers in international conferences. She has provisionally published 7 Indian patents and 1 copyright. She has 1 copyright granted. 2 more Australian patents have been filed and waiting for grant. Her areas of expertise include IQAC, curriculum planning, NBA, NAC accreditation, cognitive psychology based assessment, etc. We welcome you, ma'am.
Yeah, thank you, sir. Thank you for introduction. Welcome you all professors to this session. And it is almost, I have planned, what to say, practical session. I would like to know how many of you have acquaintances with Python programming. I would like to know, just raise your digital hand. So that would be the signal for us also. How many of you are active right now to participate into the session? I would like to know how many of you know Python programming. Just acquaintances more than sufficient. Just please raise digitally hand. Okay, no one is ready. Yeah, one member raised digitally hand. Thank you very much, sir. All right. Okay, just I would like to have confirmation with you. Is it visible? The material is visible. I would like to know from you because I am into different window. I request you to confirm any one of your audio note.
Yes, ma'am.
Yeah, thank you very much, sir. This is kind of the material what I'm using. The beginning itself I'm ready to share with you, and at the end also I'm ready to share with you. You just confirm by reaching this material. Are you able to reach here or not? Hope so every one of you can access chat window. I'm not sure chat window is not working. Okay, maybe chat enablement is not available. I'm not sure what is happening. Okay, all right. Let us move on, and I can pass it on to organizing team. Nothing to worry about it. Yeah. So just the topic of discussion: fresh water, the lifeline of nature and humanity. So if we want to live healthy, happy, and first for basic survival itself, fresh water is essential. Originally, the water is originating with this purity, but when it comes to our home at the tap, what is the problem happening? Even in the environment wherever it is stagnated, there also the quality is deteriorated. So what are all the reason? Something the fundamental you would have seen last day, but quickly within half an hour up to 6:30 we can look at some aspects of theoretical discussion, because I may be looking at different perspectives, the other speakers may be looking at different perspectives. So why it is the moment if it comes to the tap, then lot of materials involved in carrying the water, number one. Environmental factors, number two. The origin, the nature is providing the purity, but how it is contaminated only by human, I can say. Most of the time, 80 to 90% of the time, human only creates the contamination. Then human only predicts contamination. Human only uses AI for quality monitoring. All of these three is carried out by human only. So this beginning point I would like to know, why is water quality monitoring is important? Fresh water shortage, pollution, these two are the biggest global challenge, not only within India. across the globe. These two are the biggest challenge right now the human race is facing. So every one of us, we are accumulating wealth a lot, but whether the future generation could able to survive on the planet Earth is the next question mark. So that natural asset we may need to preserve than even accumulating wealth. That there is a time or it is a right time to shift or focus our attention towards maintaining the clean and hygiene environment. Anthropogenic, this is the reason I said human is the reason for contamination. Anthropogenic, caused or influenced by humans directly, indirectly, in terms of industries, in terms of burning plastics, in terms of materials, dumping all of the waste materials, then waste yards. It is a gallery of yards. People are accumulating yards. This is a waste yard. These are all the things are threatened to the environment and to the water quality. So this is not only polluting the water, indirectly it pollutes the human health as well. Water is the highest consumed item by the human being. When we want to eat food, again, water only plays a pivotal role. Even if you want to eat raw vegetable, raw fruits, again, water quality matters for the quality of the fruits and the vegetables. And when we drink, next to the food, we consume water a lot. So then it is a need of monitoring the water quality. 3 level, large scale. Large scale means kind of open lakes, open ponds, open whatever, open nature, inland water that we may need to take care. Subsequently, Panchayat municipality water tank, large scale water tank accumulation. Then the last is when it comes to our water tank, residential water tank, or it comes to the apartment water tank, that is a small scale. Further, if we want to reduce at our home, at our tap, how the quality of water comes. So that is the next question mark. These are all the levels. Every level, what is a way we need to use to measure the quality of the water will vary. Every level, how do we predict the quality of the water? It will vary because the instrument what we are using, how much geographical location we are utilizing, or quantity of the water, or amount of the water, these all matters a lot. India's groundwater has been contaminated with several substances that are life threatening substances: uranium, arsenic, and fluoride. Uranium will damage completely kidney. Arsenic will create cardiovascular diseases, kidney, and cancer. Even uranium also will be the cause for cancerous diseases. Arsenic also highly playing a pivotal role for the cause of cancer. Fluoride, it will damage the bone and the teeth. So these are all the way water is contaminated. Now, if we notice, this water is not the surface water, groundwater. So we may need to be careful with the groundwater also, turbulence and minerals, how much quantity it is permitted, all we may need to monitor. Nowadays, it is not at all reliable to consume any water. That is a level. Now we may ask another question. Then packed water is good. Always let us buy the packed water. Just yesterday night, I read the article. I didn't preserve it. Packed water is the most dangerous food consumed by the human race, declared by FSI. So this FSSAI is the certified food for this accreditation. They will be certifying it. So they have certified that packed water is the most dangerous water. Packed water. Why? Because microplastics, nanoplastics plays a pivotal role in that, because they are putting in the plastic bottle. That is one of the reason. And I have not read the complete article. So, but it is declared that packed water is most poisonous food in the planet Earth. That is a point they are claiming. So packed water is poisonous. That is a point. It is not toxic. Highest toxic. That's it. Uranium, 12 Indian states. It is predicted in 21 to 22. Even now, a lot of news articles are coming up every month. You may read about water quality. So a lot of states are several states prone to uranium contamination. Punjab, Uttar Pradesh, Rajasthan, Delhi groundwater. Next is arsenic. This is another kind of contamination. Again, this is in different states: West Bengal, Bihar, Uttar Pradesh, and some other states. Fluoride is also. So here contamination is mostly due to rock water interaction, groundwater internally in the tectonic plate. What is a chemical reaction is happening? What is a pressure is created? How the tectonic plate movements are happening? How when the plates are moving, one of the zone may be volcano erupted zone, that tectonic plate may be moving other end. When these plates are moving, then the minerals and other compositions presence in the water will be entirely different. Again, it is reason for carcinogenic, cancer related diseases. Next to fluoride. So these are all the reasons. Then last is salt content, salinity. So that is also will be creating, that also will be creating hazardous to the health. So these are all we may need to monitor. For this, the moment we say AI, AI demands data set. AI demands voluminous of the data, not a small scale data. When we are using machine learning, maybe probably small scale data we can utilize. When we are going for a deep learning, large scale data is required. Then with this itself, we can able to discriminate. When the large scale surface, when we are monitoring the water quality, then we may need to use AI. Small scale, it is not required. At home, we can predict or we can monitor, is there any unusual pattern is happening every day when we monitor? So that range we can write it down. One strip is sufficient, or a couple of sensors are sufficient to monitor at home, but nothing to predict. Periodically, it can be injected to the mobile messages. We can integrate with IoT, Internet of Things. That's all. Sensor data will be pumped to the internet or will be pumped to the cloud. From the cloud, it will be pumped to the mobile messages. Then we can able to understand, okay, this is the threshold, this is the threshold, this is the threshold. Then these are all monitored under the threshold. Then that is sufficient. Nothing to predict. When large scale only we may need to predict. So when the data is in need, how we may need to generate the data, from where we will be getting the data, that is next question. Spectrophotometry, this is one method. So it starts focusing on concentration of several chemicals like nitrates, phosphate, etc. So many chemicals, iron also, or so many molecules or compounds it will be identifying. So that one method. Then we can able to see that all of the levels are quantification. Based on that we can take data. Next is chromatography, gas chromatography. This is one method. Liquid chromatography. This liquid chromatography is used in the health sector as well. Homocysteine, one of the blood parameter reading. This is possible to detect or predict only through liquid chromatography. Mass spectrography, another method. So to then titration techniques, these all in the laboratory itself we would have observed. Chemistry teachers would have taught like this titration techniques. So it is available within the laboratory techniques itself. This mixing of chemical, how it is changing the color, how it is changing other kind of reactions. Based on that they will be taking decision. Electrochemical sensors, now from this onwards it's possible to utilize AI, whereas these are all the technique AI may not be possible to utilize. Single reading only it will give. Then that single reading, how we can able to do? So profiling. Whereas the sensors are deployed, periodically it will pump the data. Then periodically we are not able to analyze those data, whatever is streaming. Then we may need to deploy certain algorithms. Then that algorithm will give the alert message if some deviation happens. So that electrochemical sensors, whenever we deploy, dissolved oxygen measuring, pH measurement, conductivity, specific ions, That iron also has ion, nitrate, ammonium, so many minerals we may need to identify. Optical sensors. This is useful for finding the organic material, chlorophylls, small algae, small plants, we can say kind of plants or microorganisms that will be developed, fluorometers. Turbidity meters, suspended particle. This is living organic material, whereas this is suspended particles. Is some of the molecules or some of the minerals, when it starts communicating with each other, it can form a kind of particle, hard particle or larger particle. We may not be able to see microscopically, but it will form a particle, micro level, nano level particles. Instead of water, liquid bonding should be there between O and H. Other than O and H bonding, H2O is the formula for the, what to say, chemical equation for the water. Other than that, any other reactions or bonding is found, that is said to be a particle. Then biosensors. This is useful for identifying the pollutants like pesticides and heavy metals. Next, microbial biosensors. This is to find out biochemical oxygen demand. So within the water, how much oxygen is present and how much oxygen is required in order to identify that. Then next is biological methods. They may take some kind of algae or micro invertebrates, small organs they will take. With that organ or that species, they can able to identify the quality of the water itself. Certain algae will not even grow if the water purity is good. Certain algae will keep growing when the water quality is going down. So something like that. Toxicity setting, testing based on, again, aquatic organisms. Even using fish also, it is possible to test the quality of the water, it seems. So metagenomics, then DNA of all of the algae, then going to the genomic analysis, microbial, all of the algae or small micro invertebrates, taking it and analyzing. These all biological method. The next method is autonomous surface vehicle. Some of the autonomous vehicles or robots, we can say kind of robots or drones, we may need to what to say, pass it on to the surface of the water when it is large scale. Kind of in Bhopal, 50% of the Bhopal city is occupied by only one lake, that is Bada Talab. That is in Hindi, that's all. Bada means big, Talab means lake, that's it. So even in the flight, when we are traveling, we could able to see that largest lake. Then that is a major source, or only one of the source, I can say. That is one of the source for supplying water to the entire Bhopal city. Then they are in the position to take care of that water quality, or they are monitoring, or they are treating with several techniques before passing it on to the residential area. So autonomous surface vehicle is required in order to monitor that. So it will take the reflection of the water. It will take, there are several techniques again, remote sensing method, drone method. So these are all the way it will take. RGB picture also it can take, Sentinel-2 pictures also it can take, or it can take some kind of geospatial data. It can take geospatial data as well, satellite images also. Then another method is satellite image. There is a keystroke issue. Satellite images. So these are all the way it is possible to identify. Remote sensing technology, radars. There is other type of small flying flying mediums they will be sending, and it will be monitoring and taking the data, spectral data, and about the water quality, satellite images. So then, which algorithm we need to use, that decides based on the type of the data. Number one, type of the data. Number two, volume of the data. These two decides the type of algorithm. For that A matter, I will touch upon within 5-10 minutes. Small scale analysis, field kits, small scale, only quantifying one well or one bore well. So something like a small scale or only one item we want to verify, or only one water tank or one municipality water tank, something like that. So test strips, then calorimetric kits for pH, chlorine, hardness, and nitrate levels. These all we may need to. Sometimes chlorine, government what to say, officials, they themselves recommend to use chlorine for the destruction of E. coli. But the chlorine level goes more, vomiting, nausea, diarrhea, so many other side effects people will face. Even kind of intestinal ulcer also it will form. Chlorine is very dangerous to consume also. So even within the threshold level, it will be sensitive to certain members. It will not be sensitive to certain members. So that is another threat. Then portable digital meters, then chemical test they will be doing, kind of specific ions or iron or ammonia. Only these two it is possible for drooper based kit. They can just dip, it will identify only these certain elements or certain molecules or certain ions only it can do. Then biological indicators, these are visual observations, microscopic level. So using microscopic, it is possible to identify algae, micro invertebrates, these all. Then portable spectrophotometers. Then this also based on chemical analysis. Everything will be physics related, chemistry related, sensor, again it is electronics sensor related. There are several way. It is a kind of multidisciplinary subject. Then next is medium size. Then how medium size, a small lake, small pond, how to monitor in such case. So our gravimetric analysis, titrometric methods, alkalinity, hardness, then chloride content. This is for only measuring suspended solid. Everything it will be little different. Then spectroscopic method, then UV visualization, ultraviolet rays visualization, spectroscopic. Within that, it will identify certain chemicals, nitrates and phosphates, something like that. Then microbiological test. So within that, membrane filtration, multiple tube fermentation they will be doing for detecting the bacteria. Mainly coliform bacteria, E. coli we would have heard. E. coli is one of the dangerous bacteria that causes again nausea, vomiting, diarrhea, this all. So next, sensor and probes. There are several sensors, physical sensors nowadays available, pH, then temperature. It is possible to analyze several. Nowadays, advanced sensors are so many are available. Then next is portable gas chromatography. Already we have seen laboratory based gas chromatography, liquid chromatography, here portable again. Large scale. Now, this is where large scale only it is possible to pump most of the data, and it is possible to apply AI and machine learning larger extent. Rest of the items is very difficult to apply AI and machine learning because of inadequate amount of the data. Atomic absorption spectroscopic, then spectroscopic images will be available. That spectroscopic images will be useful even for seed quality analysis before even showing or going for the crop or cultivation. Seed quality is possible. Spectroscopic is a method to analyze the quality of the fruit, quality of the vegetable, so that we may not cut and do. It is possible to analyze those all, and how often it is taking to what is the time duration it is taking for the rottening. These all possible to analyze spectroscopy. At what temperature the food deterioration is slowing down, these all they will analyze using spectroscopic. The same method it is utilized for the water also, identifying lead, mercury. These are highly dangerous elements, lead, mercury and arsenic, water analysis. Then inductively coupled plasma mass spectrography. This is another method. Now finally coming to the big data, or kind of what to say, image data. Then this is chemical parameter, biological parameter, physical parameter. What and again parameter. Then images, smart sensor, IoT integration, data analysis with machine learning. Images it is possible. That images only I said, remote images, satellite images, then drone images, autonomous vehicle images. These are all types of images. Physical parameters, what and all we can able to analyze. Turbidity of the water, color of the water, temperature of the water, totally dissolved solid quantification of the water. Then chemical parameter, pH, alkalinity, hardness, then other nutrients, nitrates, phosphate, ammonia, heavy metals, organic, inorganic contamination, these all. Biological parameter, E. coli, coliform bacteria, pathogens, a lot of pathogens. The entire world is occupied with microorganisms. Even in the space in front of me, lakhs together microorganisms are living. So within water, what of reaction each of the microorganisms are there. To my knowledge, none of the technique available to analyze all of the three. We may need to utilize different strategies and instruments for reading the physical parameters, for reading the chemical parameters and biological parameters. All of the three will vary. Sometimes, for example, all of the microbiology or bioengineering, biotechnology, these specialists, always they focus on biological parameters only. Similarly, physical people, they will look, physics related people, they will look at only this. Chemistry related specialists, they will look at only this. Or within physics and chemistry related people, they may look at a couple of parameters from this and this also. But the biological experts look at only this. All of the measuring methods are different. The expertise to identify is different. Expertise to clean is different. Our filtration is different. So these are all different. So that is why everyone starts specializing into their own level of boundary. Next, to smart sensors and IoT integration. So sensors are possible to analyze pH, turbidity, temperature, conductivity, dissolved oxygen, possible. There may be several sensors nowadays may be available, or people may be conducting research for all of the parameters identification also. So that is why government is paying a lot of fund for discovering new sensors. Any new sensor, whenever we are ready to discover, then it is possible to get a lot of fund. Then within these all the parameters we can understand, analyze, and we can start formulating the principle of design. Then we can experiment with the sensor creation or manufacturing. Then we may need to test and validate. What and all we can do, machine learning algorithm, then predictive modeling we can do. This I am slightly postponing, next we can do. Next, what is the other of water contamination is eutrophication. Eutrophication is due to animal waste, animal cow dung, other fertilizers. So these all run off and it will create fungal, algae. This is another way of water contamination. One is human, another one is other animals and other waste material of even trees, leaves, stems, infected leaves, infected stems, infected flowers or vegetables or rotten vegetables, all also will be creating eutrophication nature. Then automated decision making, remote monitoring. Once automation is done, remote monitoring is possible. Now we will slowly step into AI aspects. One is AI with edge computing. What it is on site of that water body, it is possible to bring a small device, edge device. That device will have processing capacity. Then whatever the sensor data comes into the device, all of the data it will start analyzing and it will provide the result immediately on the spot. In terms of either we can connect with the PC or we can connect with the mobile, or we can just give the display monitor. Then within the display monitor it may be displaying, that is edge device. Or even edge device can cohesively work with the internet. Then the internet of things, IoT, it can become. Then it will be, what is the meaning is, instead of processing it on the cloud, the device itself will process. Then the final information only will be deposited into the cloud. Edge computing is becoming highly popular. Why? Because pumping the data or storing the data on cloud is a costly affair. In that case, to reduce the consumption of the cloud memory space, people started bringing edge computing. All of the that data they will be cleaning, analyzing, the final essential or vital signs only will be transmitted to the cloud. For example, traffic analysis. Every on the road, when we are violating the traffic rules, especially NH roads, and whenever without the nameplate, when the person is traveling on the bike, in that case it will capture. So that capturing only default people, default members information will be sent to the traffic police officer. So rest of the data it will destroy, because that camera will be having the potency of edge computing. It will start analyzing. So the moment every image, it will keep on capturing the photos, but all of the we may not able to dump. So where the violation is happening or which is essential, those are all the photos will be dumped onto the cloud or the server. So for that, what they are using is edge computing. So within edge computing, what the appropriate algorithm? Before installing the edge device, we may need to take decision with our normal laptop or normal process, GPU or CPU. What we need to do, how the data looks, everything we may need to test, and final algorithm only we may need to keep it to work on the edge computing. So that is edge device. Camera itself is edge device. Especially traffic camera has within the camera itself computational power it has. Then integration with the blockchain. So that will be transparency, it will be maintaining. All of the stakeholder can be connected. For example, municipal officer, biology expert, physics expert, chemistry expert, computational expert, all of the experts can get connected together and they can transparently show the data. Something goes wrong, then what is unusual is predicted, then who can solve this, all they can able to do. Just 1 minute, I'm switching off the camera. Yeah. Now that is for blockchain. Then advanced robots, autonomous drones, robots for sampling, monitoring. For example, one of the research paper I will be showing you. In that research paper, it is very difficult to touch that water. Such a contamination. Very powerful contamination water. In that case, it is not possible to touch and verify. Then we may need to deploy the devices. Just a minute. Yeah, sorry for the disturbance. Then advanced robotics only we can send, or drones we can send. So these are all the way it is possible to analyze. Sometimes deep depth of the lake is also will be too heavy. Then in that case, we may not able to verify. We may not able to dip and we may not able to see to it. So in that case, we may need to apply only autonomous vehicle. That is the only way to verify. Then next is AI driven policy making. Then when it is AI is deployed, it is possible to verify AI driven policy making. That's it. So then coming to what are all the hydrological monitoring methods available, what and all we can able to analyze major elements, metal concentrations, sodium, magnesium, these all only. Most of the filters, water doctors, what do we use? It starts filtering some or all of these elements. So these elements, one is sodium, magnesium, potassium, calcium, aluminum, then chromium, ferrous, then whatever I know, I remember zinc, because I'm computer science, this all almost forgotten. Cadmium, copper, arsenic. So these are all PB lead. So these are all it is useful for filtering or identifying. So next, satellite image processing, thermal processing. It will start analyzing the temperature rise, amount of dissolved oxygen in it decreases. So more the temperature temperature, dissolved oxygen will be decreasing. That will affect all of the microorganism. The moment microorganism metabolism is changed or it is dying, then that will also pollute the water. Real-time monitoring analysis, then UV spectroscopy, then satellite image, the next is drone, unmanned aerial vehicle, and sentinel. These are all the possible ways available to acquire the data. Once data is available, then we can analyze with any of the computational technique. Now, machine learning, when we need to use numerical prediction, whenever we want to predict, for example, dissolved oxygen, we may need to quantify, and turbulence we may need to quantify numerically. Whenever we want to predict, then we may need to use regression model. Then linear or non-linear, these are two major types regression techniques. The relationship between dependent variable, independent variable, then we may need to analyze what is dependent variable, what is independent variable. For that, I will explain with one example after 5-10 minutes. First, let me cover up the holistic way how or what algorithm we can choose. Linear model, when the relationship between two variables are linear. I can give now itself one example. For example, food and weight, I am writing. What will happen? Food and weight. When I am increasing my food, the amount of food, quantity of food, what I am eating, then the moment I increase, then it will be increasing my weight. So now, when I increase, both will increase. When I decrease, one of the amount quantity when I am decreasing, then slowly my weight also will decrease. Increase or decrease, it will be linear. If it is not happening, one keystroke issue, if it is not happening, then it will be non-linear. For example, I am the only person. 1 year I am taking reading. Every day I am slowly increasing 50 gram food. I am increasing every day. 365 days I am increasing too much. Then my weight is also increasing. Then this is also linear. When I am reducing my food 50 gram every day, every month, something like that, then my weight is also reducing. Then this is also linear. But it is positive correlation will exist here, negative correlation will exist, but it both are said to be linear. But if it is zigzag, no relationship at all. It happens with most of the people. There are people so fatty, they will consume smaller amount of food only, but they will look fatty. Then there are lean people, they will eat too much, they will look fit, be lean in appearance. So that all of the situation, it will form non-linear relationship. Definitely it will not form a linear relationship. Linear means one line. Non-linear means other than line, any shape. It should be W, U, V, X, A, any shape, half moon, full moon, parabola, hyperbola, or elliptic, anything. According to the relationship only, we apply linear or non-linear regression model. Next is categorical. Whether the water is toxic or pure, potable or not potable. Then if that prediction is taken, then it is said to be categorical prediction. The popular algorithms are logistic regression, decision tree, random forest, KNN, support vector machine, and naive Bayes. Everything is fully based on statistics and the probability. Then one language is required. That's it. Then understanding how does that algorithm works is purely based on statistics probability. A little bit of differentiation also will play a role. Integration also play a role. That's it. There is no other mathematics. Then when we want to implement it, we need certain language to communicate with the machine. It could be a Python, R language, or MATLAB, Java. These are all. The Python is the highest or high utilized language for the machine learning, deep learning. That's why I'm starting with Python, and subsequently R language, then R programming. Next is Java, MATLAB. Third is Java, and some people may use C, C++ also. That's it. So these are all the way categorical prediction. Nowadays, in this internet era, ChatGPT era, it is possible to take code from any of the GPT. If I ask logistic regression for these 6 parameters, how to write a Python code, just to put it in the ChatGPT, it will give the perfect code. But we may need to understand intricacies. That is the highest. That also possible to take inference from the ChatGPT, but we need to have some input with us. What are the parameters we are going to analyze? How it is going to vary? And what is the code? How to plug in the data to the code? And how to execute? And how to see the result? How to interpret the result? Interpretation of the result also we can leave it to GPT. But 30% at least we should know how to work with a machine learning model or deep learning model. 70% easily we can learn it or take a support from GPTs or internet. So these are the 2 ways it is possible to take input for learning machine learning. It doesn't matter whether we are expertise in this arena or not, or just our interest is more than sufficient to learn. I am going to do one of the coding notebook within 10 minutes. Even using your mobile, you can code and learn one by one what I am telling. Next is time series analysis. When it is useful is, for 1 year I am maintaining the data, 1 month I am maintaining data, and I wanted to analyze periodically, or I wanted to analyze the pattern among every month. There are 4 seasons. Every country, everywhere, there would be 4 seasons. Most of the countries, not every country. So winter, summer, then fall, spring season. We have some seasons, right? Rainy season. So these all of the seasons, how the pattern of the water is there. That way, when we analyze, series data is required. Just numerically predicting yes or no type, categorical. Category means yes or no, cancer or not, portability or not, or drinkable or not. That way, when we predict, there is categorical. So if you want to understand the pattern based on the time or season or month or something like that, anything unusually happening in the environment, by the time how it is happening, then time series. Unsupervised algorithm, that supervised means labeling data should be there. This all said to be supervised data, whereas this is said to be unsupervised data. That's all. Only 2 difference. This is supervised data. So what way we can do? And here, dependent variable, independent variable, both are required. So we need a data for labeling. Labeled data is required. What is labeling means? This all happens. Next I will show here one example. See, potable. 0 means not drinkable. 1 means drinkable. Being 6 chemist or physicist or biologist or water specialist, somehow manual interference is required to label first. For example, pH value is not available. Hardness amount is this solid amount, chloramines, sulfate, conductivity, organic carbon, and trihalomethanes and turbidity. Based on these all, the chemist is telling it is not drinkable. Similarly, pH value is also available. Sulfate value is not available. Maybe sulfate is not present in the water also possible. So then that is why water taste is changing from one place to another place. One person house taste is entirely different from other person house taste. Similarly, water filter also will change. Why? Because the type of filter, type of membrane, type of chemical, what it is used for bleaching or cleaning, that also matters. So now these all again labeled as 0. This 0 means in this data not worth for drinking. Portability is failed. That is the way. This is one of the popular Kaggle data I have taken, and that code also available on the Kaggle. But how to code we ourselves? How to change something? When we code it, whatever existing available and understand it, then only we can change the algorithm. We can modify it. Now this is called labeling. These are all said to be independent. Portability is dependent. Whether the water is drinkable or not is dependent on what? That is what earlier I said, dependent, independent. Portability is dependent on pH. That one itself sufficient, pH value. either it should be acidic nor it should be too alkaline. It should be moderate. It should be in the middle. So that water only advisable, safe to drink, safe to cook. So that portability. Similarly, this should be labeled. Then what range it is advised to, because only 5 rows displayed, more rows when we display, then it will be available. I can even show. So this water portability is already, I have downloaded. That if I open it, then easily we can able to understand wherever the one is there, that all drinkable. That's it. So see, most of the time it is not drinkable, zeros. Then one, they would have kept it in the bottom line. Yeah, lot of ones are there. That means the total records available, records or observations are 3,300, almost approximating. That's it. This much data required for machine learning. Deep learning, tremendous amount of data, number of columns also should be do more. Complex data only we need to use deep learning. Otherwise, deep learning is not required. This always we need to prefer only machine learning, simple models. That's all. Because data, number of columns also lesser, number of rows also lesser. So now this is one. That means this whenever this reading is there, it is advised to drink. This is identifying, human only identifying. Human, first we need to teach to the machine. So whenever there is no data, it is not available. It's not available, whatsoever may be the reason. Sensor failure, or in that water, that particular element or particular ion may not be available. That is called sulfate. Only in this column, most of the time, the null value is available. Similarly, in the pH column, null value is available, not available. That also we need to clean it up. Before submitting the data to the machine learning model, it should be cleaned. That is called data cleaning or data pre-processing, they used to call. So that has certain steps that let us see one by one. Now here, these are all the way we can work. K-means clustering means it is used to identify certain patterns and anomalies, extremities. It will identify whichever the records are not fitting into the group, that all will be outstanding. It will not comes into the pattern at all. Sometimes pattern itself may be a dangerous matter, or sometimes whichever not fitting into the pattern can be called as anomalous. That also may be dangerous pattern. So this is unsupervised learning. For this, no need of this label. This portability is not required. Rest all we need to give. Within this, it will start finding out the pattern or anomalies. Next is principal component analysis. When we can use is large number of columns are there. For example, every ion I am calculating, measuring. Chromium we have seen, potassium, sodium, calcium, everything we have seen. No, then when I start measuring every element, then biology element, the number of columns would become voluminous. It can be even 40 columns. When more columns, machine learning will perform poorly. Overfitting is also possible. So in order to avoid that, we may need to reduce dimension. Again, it is simple eigenvalue, eigenvector, only the major mathematics. It is eigenvalues, and childhood days we would have studied. It is possible to learn within a minute also. It is a matrix operation, eigenvectors. Based on this only, it works, it behaves, eigenvalues and eigenvectors. That's all. So this is called, we using this, which is possible to find out the principal component. That means it will transform the data to different plane, different dimension. Within the dimension, it will maintain the variations among the data. That highest variation will be there in first principle. Next principal component, next highest variation. Slowly the principal component is coming down. The variation will be coming down. Then when the number of columns are too many, it is after 4, 5 only now in this data. But if it is 40, 50, 200, 300 columns, especially image data will be too many columns, because image will be represented rows and columns. So then data points will be too many. In such a case, we can utilize principal component analysis. Otherwise not required. Deep learning, when we need to use, when the data is complex in nature, higher volume in nature, with respect to rows and columns, then we may need to use. If again we want to analyze time series pattern, seasonality pattern, or some kind of pattern based with respect to time. Time means date and time also. Weather data is time series data. Whether it is providing 23 degrees Celsius haze. So this is how it is giving. It is time series. So at this moment, what happened in the past history and now also what it is happening based on past history and now together it will past history when it will take no today's data I can able to see even Microsoft Edge I can able to see 2026 entire year data also. If you type this weather, it will give 2026 entire 2026 I can sit and do. This is analyzed. The moment I go to this monthly to somewhere it will be there. I need to somewhere it will be there. I don't know where it is now. Okay. So when I go to 2026 also I can analyze. Sorry, 2025 I can analyze, not 2026. How it is giving based on historical data. So it will analyze based on the now for example, what is the guarantee it will be 29 degrees Celsius on 12th? 21 degree daytime degree is 21. Look at here 7 degree. So this is prediction, may happen, may not happen. This is called prediction, but at present what it is showing is the real now the sensor data is given. For the future when I see, it is called prediction. For the present it is doing, really it is doing the present data, that's it. So in such a case time series only used. Weather data is very complex data. Too many sensors are working for us. Our satellite is working for us. Sometimes they will mix satellite data and sensor data also. They will validate with different ways also. In that case, RNN, GRU, BiLSTM, LSTM, these are all, and attention based LSTM. There are several variations available. So mainly we need to understand RNN, GRU, LSTM. These are all the base vanilla flavor 3 models. So every model, again the mathematics, the mechanism will vary. Then we can analyze all of the models also. Comparative study we can do, and finally which is working better. With that we can improvise the accuracy, or we can publish a paper also. That's all. Image based convolution neural network. Image means convolution neural network only can work. Auto encoder is variation of CNN only. What is the difference is it is unsupervised auto encoder. The same, if the data is too much or complex nature, then identifying patterns and anomalies, we need to use auto encoder. If it is supervised labeled data, this reflection, how people identified based on image. When I heard this first time, exactly 2 years ago, one set of students have come. They said we want to write a research paper based on water quality prediction using image. I was shocked how it is possible image. Yes madam, it is possible, they said. Then I started myself exploring, because before advising to them I should know. 2 years before I started exploring, then based on water reflection, illumination, people started identifying. How it is possible to identify? The next question. It is possible to identify based on, they will be looking at a different pattern of images, illumination and reflection. Then parallelly they will be verifying with sensors, or the valid or traditional technique. In the traditional technique, if with this illumination is there, what is the way it is labeling the water quality? If this reflection is there, what is the way it is labeling the water quality? Daytime, nighttime, that all they will be parallelly verifying with the sensors. The traditional method or microscopic method, whatever that we have discussed, gas chromatography, liquid chromatography, whatever they were using traditionally to analyze the water, that they will be interconnecting, interlinking. Then that kind of pictures they will be taking and labeling. That itself would be one biggest research. what to say, breakthrough research we can say. Then once if this research is published, then never in the near future, machine itself can able to label the water reflection or just water image based on images, because phenomenally they would have done with different intensity and illumination levels and reflection levels. So based on that, automatically it will start providing the quality of the water with respect to traditional method. Both based on traditional method, imaging method, they will be correlating. Then autoencoder, these are all the way. Yeah, this is meant for effectively analyzing the anomaly. That's it. So this is to identify rare contamination, odd out of common. That only it will identify. What is that odd? That may be the pure water, all of a sudden complete contaminated water. Some of the places I even visited. So the water taste and the water purity, it will be like highly transparent. Some of the places I visited, the air quality, literally I went to Bhimbetka, one place, fully forest, isolated from the city. The fresh air, when I was inhaling, the feel entirely different. After returning, within 45 minutes, I reached that city or town area. Then I am observing, I feel complete suffocation in the breathing itself. I could able to see. I am straining myself in breathing. Whereas when I was breathing there, it was different. That from that I said, then the entire 1 hour I was consciously witnessing how I am doing breathing. So that odd out of, sometimes good also will be shown as out of the pattern. So it can be any way. That's it. So then last one is how we can train the models. These all pure computer science people cannot do at all. So this can be done only by the physics or chemistry or water quality expert knowing machine learning, deep learning, they can do. Why? Because physics informed machine learning. Physics laws, equations can become one of the layer of the machine learning. We used plain statistics form, these all formula. So advection diffusion equation, this could be placed as one of the layer in the deep learning model. Then it will perform well. Or
very tired of sharing stories.
anyone is discussing, anyone is giving point. Also, someone can mute them, administrator can mute. Yeah, mute all I will do. I don't know what they are doing. Yeah, fine. So these are all the way. Now almost we have only half an hour. The some of the paper I have brought, C2 is one of the word they were using. Then I was not aware. Then I have seen to it. This is it was heart touching point. Why? Because this paper I could not see full paper. This is my native place, Coimbatore. Evaluation of surface water quality of Ukkadam Lake. This 1,000 times I would have seen in my life, Ukkadam Lake in Coimbatore using UAV and Sentinel-2 multispectral data. I was so much interested to read and present in this session, but unfortunately, I was having only the abstract. The rest of the paper I was not having, so I could not do. What is the way they were using? On-site collection. C2 means on-site collection, directly and from the natural environment reading it. That's all. They are using Sentinel-2 images, then unmanned aerial vehicle images. Sentinel-2 images little different. Unmanned, again, just give me a second. What is going wrong? Either internet. Yeah, this is called Sentinel-2 images. So the Sentinel-2 image to be taken with appropriate instruments. We may need to buy a hardware. So then based on that only it is possible. Let me switch off the camera. Then, so this is Sentinel-2 image. So using this and unmanned vehicle images, the aerial vehicle images they are using. Aerial means that the space, how it is taking, and finally mosaicing the image. Mosaicing means the drone will go from here and there. My house drone may take 2 half. Then these two have to be fitted together. That is mosaicing. So based on that, it will be working. So this is sentinel images, something like this. It will show sentinel-2 image. And these all not, I don't know, only one what I have shown. See, sometimes these are sentinel images. This is sentinel-2 images. So unmanned vehicle, whenever it is administered, it will show like this. This is our sentinel images. This is for land area. Water body, it will look different. Sentinel image will be. So using these two, they were using. Then stepwise regression model they were using. Then they were finding various optical and non-optical water quality parameters. They have considered these are all the parameters, optical parameters, optical parameters. What and all, then that full paper available only we can do. What is optical? Completely image and that illusion, reflection, refraction, illumination. Based on these all only they can take. Non-optical means pH value, turbidity, solidness. These all can be said as non-optical value. Then the next paper, what I have come across this paper is little interesting. They are doing both good water and contaminated water also. This is one of the country. They are using one belt, 7 to 12 ponds, more than 12 ponds. Water bodies, 12 water bodies they are monitoring. So then unmanned vehicle also they were administering. Why? Because see, this is the pond 1, 2, 3. They are showing complete image. So after a location map, they're showing this. This is completely toxic. It seems toxic, untouched. Because of that, they are using unmanned vehicle. That means drone is also called as unmanned vehicle. Then they are using unmanned vehicle. Then photographs of the zone. What are all the way they are taking? What are all the camera they are using? They have demonstrated. In this, what they are using, multispectral data they are taking, and physiochemical data they are taking. So multispectral data is more or less image. Physiochemical means that pH, turbidity, these all, whatever we discussed, hardness at all. Then what they are doing, mosaicing, geo-referencing and mosaicing. What no? This where they are, for example, in this drone may start from here and it will start from here, then it will go and last only it will come back. So then it has to mosaic everywhere, whether it has visited or not. Mosaicing means this picture will be available first or sequence. Then which picture will be fitted together. That is called mosaicing. So they are doing mosaicing. After that, they are taking mean reflectance. They are extracting, just they are taking mean of every georeferencing pictures. Then they are going for correlation analysis. 70% of the data for calibration, what it is predicting and what is the mean value between the mean value of every picture and between the sample. They are in that particular locality, they are taking sample. Then both they are doing correlation, then model calibration, model validation, then spatial distribution map. Every area, every location, or 12 pond, within 12 pond, there would be thousands of pictures for each of the lake. Then 12 pond means 12,000 pictures also they would have used. So all they are finally distributing and localizing. This is the method they are using. This is little tricky. The way they are using is entirely not a straightforward machine learning algorithm. It has different trick of completing the model. Then data set. What are all the way we can acquire the data? Without data, none of us we can do with machine learning or deep learning. That we need data. Government of India, they have provided data, but all are long back, 10 years ago, 2001, 2002. Recent data, nothing is available. Instead, they have written, when we write to CDO, they will be providing, chief data officer, they will be providing, stating the purpose, why we want, what we are going to do, then they will be providing. Whereas this one, complete pollution data available. Water pollution, air pollution, both available up to the latest data. These two are related to Indian data. Rest all, some data point. Water World is there, IEEE is providing, some of the countries are providing. These all entirely different data. This is California government. So entirely different, San Francisco, some different country, they're providing data. And here finally, Sentinel data. If you want to do Sentinel data, Google is maintaining Earth Engine. So that Earth Engine will provide Sentinel-2 data. So if you want to work on Sentinel data, specific to India also, we need to extract from the Google Earth Engine, then we need to work. That extraction itself little different than that we may need to do, then only we can do. Now, this is the hands-on notebook for another half an hour. 6 o'clock we started. Yeah, 20 minutes we can discuss this Colab notebook. Easily we can work, no need to install. Without installation, we can work with Colab. So next, coding practice in case if you want to do with different data, I have provided some set of notebooks. You need to have basic of Python, only based on Python with the data with the code. I have provided code also available. Whereas these are references, some of the papers I have got. These are all the questions when we coin it could be one of the wonderful conference paper, one of the wonderful research paper, wonderful bibliometric analysis paper, wonderful review paper. How do autonomous surface vehicles utilize? These all you can read later, or you yourself can coin a lot of questions. This is called research rational. So why we are ready to publish this paper? These are all the 5 central questions answered in this paper. That will create interest to the readers and the reviewers also. Immediately they will accept. So how to do research in this paper direction. After this 1 week of workshop, definitely it is possible to become expert of water quality management or this all. Yes, I had gone through the brochure. It is a diversified topic. Everyone will talk in different perspectives. Culmination of these all definitely will over anyone to become water quality analyzing expert. It is possible. Now I am going how to share the material. I don't know. Organizing team, can anyone help me? Because here itself the material is available, and here also this notebook I can share, and I don't know how to reach the audience. The chat window is not working for me or to everyone. I don't know.
Madam, the chat window is not working. We will send a presentation to the whatever the material you share. We will send to the participants. Madam.
Okay, sir.
Actually,
That's fine,
there's
sir.
a option. Yes, madam. In ATAL, the participant web page itself, there's one option for we have to upload all the resources, madam.
So that
From
is
there
fine,
also they can
sir. That
download.
story I don't want, sir. I want
Uh,
to make them to work. That is the purpose.
now,
That story I
current.
know. That story I know,
Yeah,
sir.
current.
That yeah.
Okay.
If
Now
not
we
possible,
need.
let us leave. I wanted them to work along with me. That's it.
Currently,
They
I will
need to
add you
see.
in that WhatsApp group. I will add you, madam. Currently, I will add you. Can you
Okay.
share through that
Fine,
WhatsApp group?
fine. Okay. Let us
Okay.
discuss that on later, sir. Leave me, sir. I have only 20 minutes. Leave. Okay.
Okay, ma'am.
So
Okay.
this is a notebook, Kaggle notebook, data and code together available. Same only I'm imitating. When we were starting first time, even you are AI expert, you are also beginner because data set is different. The domain is entirely different. You are also exploring new domain. Whereas when you are expert of chemist or physicist or biologist, for you, machine learning is different. Every one of us, we may need to, somewhere we need to start and we may need to drill deeper and we need to understand how the machine learning is working, how the data set is working. So this is the data set. That downloaded data set only, this harness, this I have shown. This is on my hard disk, but how you need to do? What code I am imitating here? Little bit of bugs were there, I have fixed, and little bit we need to change the code, what it is given here, that is available. So we need to work again. If it is although available on Kaggle, we need to work again. For example, this is first picture. When I started working, the same code I utilized. It was not discriminating with the different color, same color. Then I have fixed with the color palette how to differentiate with the portability and non-portability. Something like that I did it. So it is little modified here and there. So, but this is the original or what to say, for theory you can read what they are telling. So this they are having absolute fantastic description. So I can see null values in the first preview itself. Lot of null values are available. They are telling it has to be cleaned. So they are dropping. They are not cleaning. They are not at all imputing. We can do different technique imputation also. They are just throwing it away. Then they are very, is there any non-null? Not at all. This is the way they are working. Now, this data, how to send you? Here you want to download the data. You need to log in and you should know where to go. There are 4 or 5 steps to reach the data. Then we need to download. To avoid that, how to download asset, these all we need to click, go here and there and log in. Some 4 or 5 steps are there. Avoid that. I myself have brought the data on the Google Drive. Click this and download easily. I have downloaded and I have uploaded on my Google Drive. Then that Google Drive I have pasted here with view access. You can download. Now this notebook where it is available is, this is available in the material. This is a hands-on. This only, this is notebook I'm giving for your practice. So now let us do one by one. This is said to be the moment the link is given by the organizing team, save a copy in Drive. Please use this. Then it will be your notebook, not my notebook. This with the same name you can do, or you can change the name also. That's your choice. So just no need of installation, nothing. The link, whatever given by the organizer, click. You can see, you cannot execute. What execution? See, this is the play button. I'm playing. Text is for giving annotation, say tick mark, green tick mark. That means executed. This is text is for annotation. This play button code is for coding. That's it. This much if we know, more than sufficient. Then that data we need to download into our hard disk. Then if I play this button, it will ask to upload the file. Choose the file. Whatever you have downloaded, click that and upload. Then it will say 100% uploaded. Then once if it is uploaded, this is the first step. These are not available on the Kaggle. Little changes made it for the beginner level. Then 100% it is done. When after seeing this 100%, you need to locate the file. Click this folder. This is a folder. Click this folder. All available on the Google Drive only. Simple Google Drive. This is what. Then within that, this portability CSV 2 times uploaded. No, that's why 2 times. Before coming to the session, it will be available only temporarily. Until I close this, it will be available. The moment I close this, it will go. Now just simply go here, this triple dot, copy path. That path only I have pasted. This is the name of the file. That's it. So this all steps we need to know. Now pd dot first step, what it is, import matplotlib.pyplot as plot. So this is import, means it is available secondary memory or somewhere on the internet, because it is working on the cloud. This is completely executing on the cloud. It will consume very minimal my laptop power, CPU. My CPU will be utilized very minimal. All the execution is happening on the cloud. So that somewhere it is available, it will be brought to the RAM memory. That matplotlib is one of the package used in Python for beautiful pictures, or what we can say, figures, beautiful displays, visual analytics. Then import pandas as means alias name, nickname. For example, my name, some people big name they will keep. Then we will call them by small name. No, it is like that. As plot. Instead of using this in further coding, we want to use as PLT. That's all. Import pandas as PD. What is pandas is for Excel manipulation. Anytime large data, when we want to work on the RAM memory, the data which I have shown on the Excel itself, large data, right? 3000 records are there, 3500 records are there. That data will be handled within the RAM only with the help of pandas. Loading, manipulating, changing, analyzing, filtering, calculating, anything to be done on large amount of data, we need pandas. Cbond, This is also related to visual plot. Seaborn most of the time works based on the matplotlib. So better to bring both at a time. Wherever SNS is used, that all related to Seaborn. Wherever PLT used, that all related to matplotlib in this code. Number 5. This is for matrix and all of the numerical processing. Matrix algebra, linear algebra, most of the operations carried out with this package. This package is brought, then just a plug and play game. We are not doing any coding. How it is working also, it is very difficult to understand by the beginner. We need to put effort in understanding. These are all the packages. Once if it is ready, if you look at cleanly, PD, this PD is here. That means I'm using pandas. Already I said data manipulation, this is useful. Then read underscore CSV. If it is Excel, then we need to use Excel. I'm using comma separated view file, so that CSV. That whatever the path I copied, that only pasted. That means this is the location. Automatically data will be reading. It is reading and saving it in data. Then data dot head. If you want to see 10 records, you can give 10. If you don't give the 10, by default it will give 5 record. Data dot head. So it is giving 5 records. The next is data.isNull.sum. Now we are verifying where and all the null values are available. pH null value 491, sulfate 780 records are missing. Then trihalomethanes 162 records are missing. Then highest, then combination here may be available, here may not be available, something like that. Then huge amount of record we are going to truncate. Initially it is 3500 record. Then all of the missing is when we are deleting, maybe 1000 plus records will go away. Then 2000 records only will be available. Then we cannot apply deep learning at all, only machine learning. Now data.drop NA. Just I am dropping, no imputation. This is how they have done. I am copy pasting and explaining. If we want, we can do imputation. Then we need to apply statistical approach. It is all numerical, right? Then other than this null value, not available value, rest of the values, we need to verify kurtosis, or we need to verify normal distribution. If it is normally distributed other data, then we need to take average. That average, otherwise called mean, that mean value we need to substitute. That is called imputation. How do we handle the missed value is said to be imputation. Similarly, sulfate value, this is also number I have verified. So just you can look at here, sulfate number. Then trihalomethanes number, this is number. If it is normally distributed, then we can impute with mean. If it is not normally distributed, we can try with random forest for the prediction. Same work, the same notebook, we can definitely publish a conference paper. Lot of techniques available. Here itself, how do we handle this missed value itself can bring one new strategy. What notebook I'm giving itself is possible to publish one paper. But whatever I'm telling, it has to be substituted. So random forest algorithm is the best algorithm to find out the missed values. We can apply random forest algorithm to find out all of the missed values. We no need to even go for statistical algorithm. What I said statistical algorithm is finding the missed value, non-missed value, whether it is normally distributed or not, verify. If it is normally distributed, substitute mean of the remaining values I said. That is statistical approach. We no need to do. Completely rely on a random forest approach. This is random forest approach is one of the explainable model. Explainable model means we can understand how does it predict also. So that better we can use machine learning model in order to impute pH value, sulfate value, and trithalomethanes value. Then this notebook is entirely different. What we are working is different. Here, every graph they have given beautiful explanation. Easily we can publish one conference paper with different approach strategies we can apply. So they have said one means portable. drinkable. 0 means unfit, non-potable. They have given. Then here also they have given imbalance. Everything they are giving the range, pH range should be 6.5 to 8.5. So rest all, see 6.5 to 8.5. Within this zone only drinkable water. This tail also non-drinkable, this tail also non-drinkable. It is almost normal distribution. So this tail we cannot drink. So only between 6.5 to 8.5 is administered for drinking. So they have given beautiful explanation. That's why I'm doing that as well, because we need to interpret. Now dropped, blindly dropped in this. So next we are trying this custom color. I have put sky blue and salmon. Then only I could able to get this blue and this color. Earlier it was giving plain dark blue. This blue it started giving. So then I wanted to differentiate slightly here and there, the code is changed. That's all. So this is first, whenever we are working with the classification, we need to verify on the dependent variable whether it is balanced or imbalanced. Imbalanced means too much of difference. This is not at all imbalanced, but on this they have written imbalance. It is not right also. So not balanced they have written. Samples are something, okay, or zeros are more than ones, imbalance there. Zeros, it is zeros, that's all. So zeros are more than one. They have written not balanced, not at all. It is balanced. 99% 1%, 95% 5% only imbalanced. Whereas here it is 800 records, here it is 1200 records, just to 400 records only more. So it is not imbalanced at all. Proportion is well made. That is the only flaw I found, rest all perfect. So next, every parameter they are analyzing. What is every parameter is, see, this is the data, right? Every parameter, pH they are plotting, hardness they are plotting, solidity they are plotting, and the chloramines they are plotting, sulfate they are plotting, and the conductivity they are plotting, organic carbon they are plotting. So these are all the, because whenever the carbon composition is in the water, it is organic carbon. If it is in the air, only carbon. So for every plot, they are understanding how the data is distributed, what type of data is available. So if the expert is highly good in about this analyzing this visual plot, the range, they can describe about each plot a lot. So hardness is permitted 120 to 200 milligram, but we cannot talk a lot where this data is pulled, which water body, no history is available. If it is available, we can articulate. We can talk a lot. For example, Bhopal Bada Talab, when we are really taking the data, then we can talk like a history of Bada Talab, square feet, what, we can talk a lot about that data, real time when we are doing. Now we can understand only machine learning. That's it. So here, every sulfate, finally carbon, organic carbon, everywhere turbidity, it is there. Now, if we look at here keenly, any new package installation, other Python software other than Colab, and on the Kaggle itself you can code, within this platform itself you can code. That also I would have done, I have not done. This symbol, exclamatory symbol is used. Whereas here we should not use exclamatory symbol. That is a condition of Colab. This is to install a new package to the Colab, to your notebook. That is what pip install. This is popular command, pip install. Pip is a command used, that pip only. Pip is a command used across any of the software to bring the new packages to your notebook. Default package, Matplotlib, Seaborn, Pandas, NumPy. These 4 packages I have installed very simply. Nothing I did directly importing. That means that all embedded. That is by default available. There are certain packages, especially it will perform some role when we want only we need to install. Otherwise, heavy notebook will become heavy. The memory consumption will be heavy. So that they will give it the freedom to the user, what they want, they can install like that. So now we are coming back to correlation, data correlation. They wanted to find correlation with the pH value to other. pH, alkalinity, acidity is depending upon other compositions. So that it is highly logical. It makes sense also to find correlation. Or we can find correlation to all of the parameters also. But what is logically validating how organic carbon is related to sulfate? No way relationship. We cannot write justification. Only for pH value we can do this all. That is why correlation is possible to find out between hardness to solidity, turbidity to potability. Anything we find out. But that is not that will be illogical. So that pH with other parameters, they are calculating the correlation. So now correlation, how it is coming? Mostly little bit high correlation when we see this one only. Little bit. It is not at all high correlation. Little bit highest number only. All are low correlation. There is no correlation at all only we need to say. Point 1. Hardness is directly connected with the pH as per this date. Really, chemistry teachers only they know what makes pH value to go up or down. So that's it. Now it is called lazy classifier. There is one package is available, lazy classifier. That was I was highly expertise, but this is the first time I'm using PyCaret through this Kaggle notebook. Lazy classifier will give more than 20 classification, whereas it is giving lesser than that PyCaret. So this from classification import star. That means you don't know how extra tree classifier is working, random forest is working, quadratic discriminant analysis. These are all types of classification. Dummy classifier, ridge classifier, linear discriminant, Adabos classifier, k-neighbor classifier, SCM classifier, decision tree classifier. Nothing we know how it is working, but using this, if we set up this classifier equal to setup data target, we need to teach to that line. Portability is our dependent variable target. Verbose false session ID 8786. This all right now not required. Without that also it will work. With that also it will work. What is the meaning means? It has entirely different meaning. That right now is not required. So this is a major point. Because only 5-10 more minutes we have, that's it. So now every classifier it is giving, see, these are all the model validation parameter. It is giving accuracy, then AUC, recall value, precision, F1, kappa statistics. But what is the danger? How this algorithm works? What are all the hyperparameter? We don't know. Some third party, they have developed the package, they set up. But what is the understanding is, for this data, this is working better. Quadratic discriminant analysis is working better. Extra tree classifier is working better. Little inference we can take. And this is the, then AUC is high for this. And accuracy is high for this. Recall is high for this. Precision is high for this. F1 is high for this. Kappa statistics is high for this. So every metric they are using what is high. But for us, AUC with respect to AUC also we can work, with respect to accuracy also we can work. This is more than sufficient. So we need to further explore quadratic discriminant analysis, extra tree classifier. This is the indication. Now we need to build that algorithm from the scratch. Only then we can write the paper. This is the indication. Which algorithm will work better? This is using only 12 algorithm. There may be 30 plus classification algorithms exist in the world. All 30 we cannot work. So we must thank God people invented some lazy classifier, that is PyCaret. Using that we can able to get quickly a short decision. With that we can develop the algorithm extra tree classifier or quadratic discriminant analysis from the scratch. Then how do we develop the algorithm? How every stage we are changing the parameter, how we are predicting the result using that parameter, we could be able to articulate well. Then we can tune model. Tuning is one of the technique. Tuning means, for example, one student is not at all studying, only capable of just pass mark. We need to tune them, right? We cannot destroy them, right? We need to give different teaching method. We need to give different teaching material. So slowly we need to help them the same candidate, same person or our own child, not at all capable of passing, let us imagine. We cannot kill them, right? We need to tune them. So similarly, what is the way they have developed? That is only 68% accuracy. If we sit and tune, and if we do pre-processing different techniques, then there is a chance of increasing the accuracy. There is a chance of increasing the AUC. Then whatever the potential models need to take up and keep working on it. That is the final conclusion. Whenever we work with different, see, it is giving some of the extra classifier. This is called hyperparameter. Only one function, but how many parameters they are passing? 20 plus parameters. So these 20 plus parameters we should able to understand, and we need to change. That is, changing is hyperparameter tuning. Number of estimators, instead of 100, I want to have 150. Why 150 also we need to justify. More the estimators, then reliability is more. Every parameter we need to study. Then we need to change. When we change, there is a chance of increasing the accuracy as well. That's all. This is what to say. Then finally, extra classifier, one classifier alone taken, and its own every stage, every fold cross validation, and it is giving how it is predicting. This is finally predicting score, how the model is predicting. So it is model is predicting 0 and the prediction score is 100%. Predicting 0. See, the original portability also 0. My model, what it is predicting is also 0. Not my model general. So the prediction score is high. That's all. So this is how it works. So it will take time for understanding and actualizing. All right. With that, I thank the organizing team for giving me the opportunity to be part of this FDP. And I thank all of the participants for your active listening in the late evenings. And over to the hosting team. And I will share the material shortly in the WhatsApp group. WhatsApp, that's it. If there are any questions, you can ask and come forward. The material within 2 minutes or 5 minutes soon after the session, I'll be handing over. If you would like to say something, ask something, then you are most welcome to ask.
Thanks a lot, ma'am. It was wonderful session, and I can see the passion from your side for this work now. So definitely I'm looking forward to work and to get some guidance from you, ma'am. We'll definitely connect you, ma'am.
Yeah, definitely. I have given all of my credentials. Most welcome for collaboration. Even together also we can publish, or I can give tidbits, whatever I know suitable for
Yes, ma'am.
research.
I'm Seema from Bennett University. I'll definitely contact you, ma'am. Thank you.
Yeah, thank you very much, ma'am. Thank you. Over to host team, and only one member is interacting. And yeah, thank you. Murugan sir, over to you.
Thank you, ma'am. Thank you very much, ma'am. Thank you.
Yeah,
It's
thank
a
you, sir.
wonderful session. Thank you, ma'am. Thank you.
Thank you, sir. I'm sharing the material within 5-10 minutes, sir.
Okay.
Fine.
Thank you. Thank you.
Then
Thank you. Thank you.
may I leave?
Yeah, yes, ma'am. Yeah, yes, ma'am.
Fine, sir.
Good evening, everyone. We welcome Dr. Suresh Kannayan to handle today's session on AI in wastewater treatment optimization. Dr. Suresh Kannayan has an interesting career in journey in AI. He started as a researcher and software engineer and later became an entrepreneur. He and his partner founded the company called Menmoli Technologies Private Limited in Trichy. This company specializes in creating new and advanced AI products and solutions. Before starting his company, Dr. Suresh Kannayan worked at RX Logic in Bengaluru as a software engineer in the machine learning team. In this role, he successfully developed solutions for extracting data from clinical forms using advanced technologies like computer vision, machine learning, deep learning, and natural language processing. His journey from being a researcher and software engineer to becoming an entrepreneur has given him a wide range of skills and deep understanding how AI can be applied in the real world. We welcome you, sir.
Yes, sir. So, very good afternoon. Sorry, very good evening, everyone. So, first of all, thanks to Murugan sir for inviting me for this wonderful faculty development program sponsored by ATAL. So, yeah, so today, as sir said, so it's the topic on AI for treating the wastewater. Okay, so that is the topic I have chosen for this session.
Sir,
Just one
your
second.
voice not audible, sir.
So is it fine now?
Yes, sir. It's
Yes,
audible,
sir.
sir. Audible.
Oh, yeah. So one second, I'm just sharing my screen. Okay, so I hope my screen is visible to everyone.
Yeah, yes, sir. Visible, sir. Thanks.
Okay. So yeah, since it is a late evening, so I directly jumping into the topic. So let me give me a second. So yeah, in this 1 hour session, so I'm going to cover only a few things. One is about the introduction of wastewater treatment, and followed by AI and ML. I mean, AI and ML, how AI and ML are being applied to treat wastewater. Okay. And followed by we do some coding and exercise. So this is the plan for the next 60 minutes time. Yeah. So yeah, since all of us are very matured and faculty members, I hope so. So I think we don't need to go much in depth about the basics of what is wastewater, where it is coming from, how we are doing some treatment. So all these basic things, I think we can simply ignore at this moment, because the major focus of this session is to understand and come to know how AI and ML can be applied instead of just simply going through the theoretical part. So I want to make a little bit of more into the AI and ML part. And so I'm just skipping a few slides, so please don't mind. And yeah, anyway, I'll be pointing out a few important points where we can see how the wastewater treatment plants are actually working in industry. Okay, I quickly go through one of the approach which is being used around the world. So the one of the approach is that the one which I have shown here. So here basically what is happening is that there are basically two parts. One is primary treatment, and second one is the secondary treatment, where if you take from the top left, okay, if we take from top left, so usually where this originates, where this wastewater originates. So basically it is either from home or office or hotels or some industry, right? So these are the base, these are our origin from where from the sink, from pipelines, so all the drainage systems are there, right? So through which the entire sewage, those are going into some chamber, okay? some chamber which is placed in some giant plant somewhere in the city or around the city. Okay. So here, the first step they do is that simply whatever disposable grids identified, those things will be filtered out in this stage. Okay, those things will be filtered out here, and the contaminated water that goes into the primary classifier. Okay, so that's the first point. So primary classifier is the physical process where where we are removing that solids. Okay, where we are removing from the solids which are mixed with this water. Okay, which are coming from home or industry. Okay, that is the first part. And in this classifier, again, so whatever this sludge comes after this primary classifier, those things goes into some groundwater somewhere. Okay, some disposal things, and the remaining thing, the remaining water content goes to this secondary treatment plant where it is pumped into the aeration tank where we have air compressor, sensors, and other electrical and electronic mechanical items over there. Okay, and here there are some loop. Okay, loop means so until we get some threshold of pH value or some quality parameters, the process keeps looping over here. Okay, so the process keep looping over here, and once it reaches to some pH level, okay, some threshold level, then it will be applied with some disinfectants to remove viruses and bacteria, and then it will be disposed to the some water bodies outside the water plant. Okay, and so what are the left over here? Those things again, yeah, come to some disposable area where again, yeah, it will again go back to the primary one and the process goes on. So this is what the treatment plant usually treat the wastewater which is coming from the domestic or industrial usages. Okay, and and it is said to be that so most of the items like 90 to 95% of these solid waste is and 25 to 75% of bacteria will be removed in the first stage itself. Okay, in the first classifier itself, most of the items will be classified. I mean, the solid sludges will be removed from the water. And and another important point so we need to have is that so usually the operating temperature which they set over here is that between 25 to 35 degrees centigrade, I mean degrees Celsius. And in case the temperature goes over 35 degrees centigrade, then the efficiency of the entire bacterial and virus removal will get reduced. So that is what this study says. Okay. Yeah. So, so this slide I just prepared just to have some basic understanding of how water treatment plants are working. Okay. So now we jump on into the AI part, and before moving to the some of the topics, I like to show you one video where they have explained how AI are being used in water treatment plant. So yeah, I hope you got some idea of what they are doing, right? So, so anyone can reply. So what you understand from that video? Anyone? So okay, anyway, so I will share that video in offline as well. Okay, that's fine. Yeah. So here now we are jumping into AI part where we will see the places where we can apply AI and ML for monitoring purpose, for reporting purpose, for enhancing customer service, for storing the water in a container, and lot of other items are there, which we will see one by one. Yeah. So when it comes to the monitoring and data analytics, yeah. So as you said in that video also, they have mentioned they are using a lot of sensors, right? A lot of sensors, IoT devices to collect information from the plant, right? So there are a lot of pipelines. From the pipelines, they have to measure what is the pressure of the water going in and coming out. Okay, and also we need to know what is the pH value of that particular water that is flowing in that pipeline, and also we need to check the chemical concentrations, right? Chemical compositions which are found in the water, right? So all those measurements we have to collect using IoT and sensor information, and using those information, then yeah, we can feed into ML algorithms, something like linear regression or classification, something like that. Depends on the data, depends on the use case which we are picking up. So we'll be choosing one algorithm and we try to predict or classify something. Okay, so that is what one thing we can do with the real-time sensors data. And so the second thing is that optimizing the process. So how we can optimize the water treatment process efficiently. That is what some highlight over here given. See, assuming we have some AI systems in the place, in the plant, water treatment plant, and since we already know what is happening in that aeration part and the chemical dosing and filtration, right? So these items, so these informations we anyway will be collecting from the sensors, right? So based on the predefined, based on the predefined values, we used to compare the real-time information, right? So we used to compare with the real-time information. If it is matching, then we can say the entire control is in proper place. Okay? Entire system is in proper place. In case the values which are in the what to say chart and the value which are we getting from the real-time data from the IoT device and sensor data, if it is not matching, then obviously there is some issue, right? Obviously there is some issue. So we need to fine tune. We need to tune either the aeration, either the filtering part, either the chemical dosing. Okay, so based on the point where the variation comes, right? So based on this, the AI algorithm should able to maintain that situation. I mean, they control the situation accordingly, right? Yeah, and yeah, predictive maintenance systems. So where, so basically, when we say large manufacturing units or large plants, okay, so where mostly we use chemical items, mechanical items, electrical items, sensors, and so many other items are there, right? So usually 24/7, the machines will keep running, right? 24/7, they used to run the machines, right? So in that case, obviously we need to have someone or we need to have some systems to monitor the entire process, or to say lively 24/7, right? And the monitoring sensor, the monitoring system that should have the capacity of what are the things happened in the past and what is happening in currently and it should able to predict when a particular sensor need to be changed, or when a particular physical component or mechanical component should be changed, so that we can optimally do the maintenance, optimally can process the entire water quality maintenance things. Yeah. So, yeah, so this one is a very interesting one. So this one is a vision-based system. So one of the company, so what they did is, so they have come up with a robot, one giant robot. What it does is, it will simply float in a river or some pond or somewhere, okay, some water bodies, and from there it will collect all the debris, okay, bottles or any other things, okay, any other waste things which are floating over there. It will simply move here and there, and then it will find where our the garbage is found. It will simply collect, and it will do some what to say, checking something, whatever the process they have set it over here, it will do and collect and clean the entire water body. So this is one of the interesting thing, which also I have found in the YouTube as well, and I will share the link of the robot. So in the WhatsApp group, yeah, in the later stage. So 1 second. Okay, so yeah, there are a lot of things. There are a lot of topics which are mentioned here, but I simply skipping because I want to focus more on the programming part rather than these theoretical points. So this one will be the final point before going to the coding. Yeah, so AI, which can be used as a chatbot also for engaging with the employees or laborers who are working in water bodies, as well as the public. Public means we. If we have any queries, we can simply go to that chatbot and we can ask whatever the queries we have. Or if the labor or if the employee who is working in the water plant, okay, if they want to train themselves about the particular plant, how the plant is processing the entire wastewater treatment and safety measures, pH levels, chemical components. So whatever information which are there, uh, which are necessary knowledge for the employees, those things can be uh, observed from the chatbot. Those things can be asked to the chatbot and get the information accordingly. Yeah. So yeah, with this few points, I'd like to dive into the coding exercise. So, 1 second. Okay, so any queries or doubts so far? Because I simply just given only the points. So wherever we can apply AAML in the water treatment plant, I just simply given the points. It's kind of notes, right? So that's why I'm just asking. Okay. Okay, I guess there is no doubt. So I simply jumping into the program. So in this slide, I have shown you some points, right? Like 7 or 8 items I have shown you. So in this code, I'll show you some sample data. Also, I will show you whether what is the water is in normal stage or whether it is contaminated or whatever it may be. Yeah, so the first thing is that yeah, monitoring and data analysis. Okay, first thing. So for that monitoring and data analysis, I have taken this code. Okay. So where I have pH level, I have turbidity, and I have water flow rate. Okay, so assume these are some randomly picked items. These are not real items. These are some randomly picked items, and based on these items, we can do some data quality monitoring. Okay. Yeah, I'm just running it. So yeah, so here actually what I'm doing is that, so I'm applying EZ score approach. Okay, I'm applying EZ score approach for my input data. Okay, so in my input data, pH level is there, turbidity is there, and flow rate is there. Okay, so based on this information, I can find whether this particular item for this particular value, whether the pH is normal or abnormal, or turbidity is normal or abnormal, or flow rate is normal or abnormal. So these things we can predict. Okay, these things we can classify. So that is what the objective is. Right? So I just run it. So it is giving me these results. So from these results, you can see in most of the places there is no anomaly, right? Only in one place it says true. It means some issue is there with this data. I mean, it's not an issue. It's like it's not meeting the standards of the water. Okay. Yeah. So I will share this source code in the chat. Murugan sir, I couldn't share. I could chat here.
Sir, chat box is disabled by organization level, sir.
Okay.
Oh.
But
If you want,
is there any WhatsApp group?
yeah, I'll add you, sir. Just now, I'll add you, sir.
Yeah, please.
Yeah. Sir, I have added you, sir.
Oh, yeah. Okay.
Okay, thanks.
So I think it's not yet audit. Sir, it's not yet added. Can you check again? Murugan sir?
Sir, wait a minute. Wait a second, sir. Yeah, it's showing it's you are there in the group only, sir. Already group.
Okay.
It's showing already existing.
Can you ping in that group, sir, so that I will know?
One second, sir. No, sir. Check.
Oh, yeah. Now I got it.
Yes, sir. Thanks.
So, yeah, the first one which I have tried here, I have shared in our WhatsApp group. So, so I request everyone to just practice this code. So in your machine. So we can take Google Colab and we can simply copy paste. It will work. And So I give you just 1 minute time. So you just simply open Google Colab and run it. So I hope all of you are from CS background, right? CS, IT, data science. Murugan sir, so everyone is from IT
Yes.
background, right? CS. Okay.
Yes, sir. Most of them, sir. Most of them.
Okay.
Some people are from chemistry, like that. They have a subject background also there.
Okay. Okay.
Yes, sir. Most of them will be from CSE backgrounds.
Okay, sir. Fine. Okay, for CS people, it will be very easy, but for people who are from a non-coding background, it will be little tricky. But anyway, it is easy only. So the people who are from non-IT and non-coding background, so what you can do, you can simply Google collab.research.google.com and then open one Jupyter notebook. Okay, and then you just copy paste this program. You just need to copy paste this program, it will work. Okay, and for running the code, you simply click this play button. Okay, and after clicking that play button, the results will be shown over here. Okay, and yeah, so here we have 3 parameters, right? We have 3 parameters: pH, turbidity, and flow rate. So if you change any value like 37 or 111, something like that, so based on the values which are changing here, the anomaly will turn into true or false. Okay? The anomaly level of this particular threshold values will be treated as an anomaly or not anomaly. Okay? So you can play with this data. So yeah, that is the first item which we have run. And second one is the process optimization. This is a very simple code only. Okay. So here, what I'm trying to achieve is that. So what is the O2 level? Okay. What is the O2 level and what is the flow rate? These two things I'm setting here. Assume these two values are taken from live sensor or some live systems. Okay, assume these two things are coming from live sensor and passed over to some predefined measures. Okay, so passed over to some predefined measures where we say the optimal water level is 8. Okay, assume these are some desired oxygen level. I mean the 8 mg per L. These are some desired oxygen level, and we want to adjust based on the readings taken from the sensor. Okay, and here is the simple equation that simply subtracts optimal O2 from the level value which we have taken from the sensor. Okay, and also it multiplies with the flow rate. Okay, so this is simple adjustments only. So here the objective is so given the measurements coming from the live sensor, so we need to set whether we need to do some adjustment in the water flow or temperature, something like that, or whether we don't need to do. So that is what the objective is here. Okay. Okay. Okay, so I have shared the entire notebook as well. So, so the next item is that predictive maintenance. Okay, say for example, we have a historical data. Okay, where we have hours and the probability which a machine can fail. Okay, so the first array is of the number of hours the machines are run and the probabilities, the probability occurrence for the particular number of hours. Okay, and in this case, I'm using some simple linear regression algorithm only. Okay, I'm just simply using simple linear regression algorithm, and I'm pausing over the usage hours and failure probability to my algorithm and building the model. So here in this stage, I have built the model, and in this stage, what I'm doing is that I'm just pausing 600 hours. Okay, so here if you see, I have set 100, 200, 300, 400, 500, and I'm trying to check what will be the probability if the number of hours is 600. Okay. So in this case, if I run this one, the model will say the probability to failure, the probability for the failure could be 0.59. Okay, and here you can set some other value as well, 650, 750, whatever value it could be. Okay, and for 650 it says the failure probability will be 0.649. Okay, so this is very simple approach for predicting whether we need to do some what is it, machine changes or sensor changes, or we need to replace some spare parts, right? So there are a lot of items involved, right, in the real scenario. So where if you know how long that particular spare part, for how long the sensor worked, how long the pipeline are being in the place, okay, if you know the exact hours, and if you have the history of the probabilities where the machines have failed, okay, if we have these two information, then yeah, we can simply build a simple linear regression model, and then we can predict the future where given the hours, what will be the probability of the failure for the particular spare part or sensor or pipeline or whatever it is. Okay. So in this case, only two items like hours and probability, but in real case, we may have a lot of other parameters as well. So that is about predicting your failure probability. And coming to automation, automated decision making. So here, it is very simple logical code only. So what I'm doing is that, so here I'm pausing the pollution level. Okay, I'm pausing some pollution level and trying to find what is the optimal dose which I need to prefer. Okay. Say for example, I have given 50, and the chemical dosage required is 5.0 mg. Okay. So these are some standards which government will give to the plant, the manufacturers. But yeah, it could be different country to country, state to state. Okay, so yeah, here comes the interesting part. So here what we can do. So as I shown you in the PPT, so this one is the last point which we have covered, where we can use AI chatbots, right? We can use AI chatbots for the interaction, okay? For knowledge sharing, for interaction, to get to know what is it? To get to know how to react for a particular situation. So all the information we can train, and then we can, I mean, we can feed the information to the bot so that the bot will learn, and when a new user comes, the bot will reply to the queries. So that is what the scenario is. So here in this exercise, what I'm doing is I'm using OpenAI, okay, and under OpenAI, I'm using Azure OpenAI. So here, one second. See, assume one chatbot is running behind the screen. Okay, assume one chatbot is running behind the screen, and so this is the question you want to ask to your AI chatbot. Okay, so here my question is, how can I check my water quality? Okay, so given this question, my chatbot, my chat assistant will reply. It will take a moment. So just 1 or 2 more seconds, we need to wait. Yeah. See here, the question which I have asked is, how can I check my water quality? Okay. So the chatbot says these many things. So use of electronic testing device, laboratory testing, home testing kits, hire a professional, and so on. Smart sensor and all. Okay. So this way, see here simply I am using GPT-4, okay, the default one. But if you want to share your own information, if you want to train the ChatGPT with your own data, that is also possible. But those things are not covered in this session. But yeah, if you want to have, if you want to train your own ChatGPT model with your own information, you can fine tune this entire model. This is also possible. If you need any support on that, yeah, I can provide you offline. So likewise, you can ask any other question as well. So instead of how can I check my water quality, you can say pH level of drinking water. See, it says a lot of information. So a pH lower than 6.5 could indicate that the water is acidic, and yeah, there are a lot of things. The pH scale ranges from 0 to 14, and with 7 being neutral. So it is providing a lot of information. So likewise, say whatever questions, whatever queries you have, you can simply pass over to here, and based on the questions given here, the chat GPT, that chat AI, okay, that will respond to you. So this will be interesting. So here, this one is my personal account. Okay, so this will be available only for today. And if you want to try now, yeah, you can try. I give you another 10 minutes time so that you can try with your own questions. Because this API key will be disabled by end of the day. So that's why I'm saying if you want to try this one, you can try right away. So at least those who are already working with the Google Colab, so I request at least try this one. Try with the OpenAI code right away. And I hope most of you are using ChatGPT, right? But you'll be using these chat options, correct? So here you will go type something and then you will come over here, right? But here programmatically, I'm pausing my query and getting the output. Instead of going there and type, here programmatically, I'm pausing my query and getting the output. So yeah, so with this point, I like to stop the coding part now. So if you have queries, we can discuss. So this OpenAI part will be very interesting one. So at least you try this. May I know how many of you are trying it? Sandhya ma'am, you have raised your hand. Do you have any query? And Sandhil sir, any question from you?
Nothing, sir. Nothing.
Okay, okay.
I didn't raise my hand.
Okay, no, it shows hand. Okay, fine. So I keep endpoint and API open. So till end of the day, okay, for next 1 or 2 hours. So within that period, you please try this code. So what I'm saying is that because these are paid versions, these are not free versions. So that's why. So only for FDP participants, I'm providing this API key. For other people, I won't be providing this one. Yeah. Okay, so anyone have completed this code? The ChatGPT one? I'm expecting at least 5 people to complete ChatGPT code. So we still have 10 more minutes. So within 10 minutes, we can run it. Okay, so if there is any queries, we can discuss. Or we can wind up the session, I guess. Murugan sir?
Sir.
Sir, if there is query, we can discuss. Or we can wind up this session. Okay, so I got one query in WhatsApp group saying that is it useful for getting the various results by asking different question in the same method? Yeah, absolutely. So you can change the questions. Okay, so whatever queries, whatever prompt you want to set, you can set, and you will get different results only. Yeah, fine.
Good
So any other
Good evening.
queries?
Can you
Sir?
send material?
Oh yeah. Yes, ma'am. Yes, ma'am. Tell me.
Sir,
Yeah, ma'am. Tell me.
how to know the performance metrics for this chart model, sir?
For
What
the
are the
chat model, right?
Yes, sir.
See, for the chat model, see, usually for the chat models, we usually don't do because these chat GPT models are built by OpenAI, right? By default. By default, um, there are two options. Either you just accept whatever is there, whatever they have built, you just accept it. That is one. Okay. And if you want to measure, the only option is that, say for example, this is your question. Okay. This is your question. And you also need to have the expected result. Okay. 1 second. See, this is your input, and you also need to have expected output. Okay. Okay. So here, I'm just simply randomly type. So here you need to have what is the output you are expecting. Okay. And what you can do, say here you know your question. Here you know what is the expected outcome. I mean the result. And here this is the result come from LLM. Okay, here the LLM is your ChatGPT 4. So once you got the result, you can compare. You can semantically compare these two results. Okay, you can semantically compare these two results, and the semantic similarity will tell you whether these two results are same or different. So that is the only way you can do. And for semantic similarity, there are a lot of algorithms available.
Okay, sir. Thanks.
Oh yeah. So any more questions?
Sir, good evening.
Good evening, sir.
So kindly after end of the session, share the material whatever you taught today. It will help me to revise once again.
Yes, sir. I will share. I will share the videos, PPTs, and program everything.
Yeah, and okay, sir. Okay.
Oh yeah, yeah. So yeah, I have shared my company link in WhatsApp group. So I request everyone to share your feedback. So here there is a review thing, right? So you can write a review for me. So simply click a Google reviews and then you just leave your feedbacks and ratings.
Hello, sir.
Sir?
Sir,
Yep.
this is a Sundar from CSE department, Weltech University.
Yes, sir. Solunga, sir.
I have one little bit doubt. In threshold value, you have to assign with the 2.0.
Okay.
I dynamically assigning with the threshold value. How it is possible, sir?
So once again, sir, which code you are saying, sir? Here, this one?
Yes, sir. The above threshold value assigning with the 2.0.
Okay, here you want to set 2.0. Right?
Yes, sir.
Okay, so these are only for experiments, sir. You can keep changing it.
Because my coding I have to change it with the myself, but the threshold values are dynamically I have to assign it to the not fixed. How it is possible? That only I am asking. So fixed means you can understand, no? That is a 2.0 is a fixed. I also assign it to the 3.0 means fixed, but not fixed. Depends upon condition based, it can be changing to the threshold value.
Yes, sir. So you just need to change the logic accordingly.
Okay.
But anyway, see, for the water quality, there are some default parameters, sir, right? So it cannot be 2 or it cannot be 20, correct? It will be between 6 to 15, I guess, right?
Okay, so okay.
So you need to put only those values. So you cannot simply put some random value, right? Like 150. That will not be a meaningful thing. Right?
Okay, sir.
But yeah, these are some fixed items as per the drinking water quality standards. Okay, but in reality, the value which are coming from the wastewater, the value may be changing. Okay, and in that case,
sir, I am asking if it is possible to changing with the threshold value dynamically.
You can change, sir. You can change.
Right. Okay, sir. Yes, I thought I think about changing with that. There is some other codings are writing with that, but some not possible to get the output. That only I am asking that.
You can change it, sir. You can change.
Okay, sir.
Okay, so any more questions?
Any queries from your side?
Okay, so that's fine. So I request everyone to leave your feedback in my Google review, please. Okay, I will share the link. Just click that link and click Google review, and then put stars as well as the comments. Murugan sir, so I guess we can wind up session now if there is no queries.
The feedback link will be shared to your list. Tomorrow's session will start by 6 p.m. So please be at 6 p.m. sharply because attendance is one of the mandatory ones. Okay. So you have to maintain 80% attendance. So please be at 6 p.m. sharply.
Okay, sir.
Okay, so thank you everyone. So for patiently listening to the lecture, and I hope this session is useful for you. And yeah, I covered only the some basic fundamental thing. And if you want to have the real use case using IoT, ML, and AI, then yeah, we can even chat offline as well. Yeah, thank you all.
Thank you, sir.
Put a